Hi gang, take two here. Okay, last video I was talking about the upper and lower bound, and I forgot to mention that if you get a zero, that can count as a wild card. So for instance, if I get out of my synthetic division a 2, 5, 7, and a 4, those are all positive. That means that I can let 0 count as a positive, because 0 can count as positive or negative, okay? So then that would mean that this here is a upper bound. So when you're doing the upper and lower bounds, if you get a 0, it can count for whatever you need it to count for, whether that be a positive or negative. Okay, so now I'm going to, I've generated the zeros. I've generated the zeros here. And we know that in the final answer we have either 2 or 0 positive real zeros, and we know that we have 1 negative real zero. So it's really up to you how you want to approach it. It's, you know, there's no hard, fast rule. Like for me, since I know for sure we have 1 negative real zero, and we may or may not have a positive, I just feel more confident starting here, like this would be a good place to start. So out of the negatives, I have 4 choices. I'm going to pick towards the middle. I'm going to go with -2. You're free to pick any of these, okay? I'm just advising you on what might be an approach. I tend to pick towards the middle because this could potentially be a lower bound. And if it's a lower bound, then you wouldn't pick anything lower, you know, if it turns out to be a lower bound. All right, so let's go ahead and do that. I'm just going to move the polynomial up to the synthetic division. So the coefficient of x to the 5th is 1. The coefficient, there's no x to the 4th here, so you got to represent it with a 0. The coefficient of the x to the 3rd is 1. Coefficient of x squared is 2. Coefficient of the linear is -12. Coefficient of the constant is 8. Sorry, the constant is 8. Just a reminder, if you're missing a degree, you have to represent it in the synthetic division with a 0, okay? All right, gang, so like I said, I'm going to try the -2. I'm going to be a little more careful this time. Let's see, so this is a 1. This is a -2. Add, this is a -2. Multiplies a +4. This is a 5. This is a -10. This is a -8. This is a 16. This is a 4. Oh, we got it. We got it. Okay, great. So remember, you've picked correctly when your remainder is 0. You've picked correctly when your remainder is 0. So that means that this is a 0 of the polynomial. Another way to think about it is that it's an X intercept of the polynomial. So let me show you what that means. And I know you probably saw it in the previous video, but I just sort of hammer my points home to make sure you get it. So this was the original, and what we did is we're about to take one linear factor out of the original. So what we've discovered here is that x equals -2 is a 0 of the polynomial. If you move the 2 to the left, you're converting it to its factored form. So if you move it to the left, you're putting it in its factored form, right? Like if it was set to 0. So this currently is a 5th degree. You've now just pulled it down to a 1st and a 4th degree. All right, so you factored one level out, so to speak. So what is left? Here's your constant. Here's your linear coefficient, your quadratic coefficient, and your cubic coefficient. So let me write them in here. Hold on a second. The hand wrote a number it didn't want to write. Okay. Got my trustworthy eraser here. All right, so this would be your 4th degree. All right, so this is your 4th degree. So the coefficient of your 4th degree is 1. Coefficient of your cube is -2. Coefficient of your quad is 5. Coefficient of your linear is 8. And your constant is 4. So like I said in the very beginning, it's very difficult to factor these polynomials. It takes a lot of steps. But what you just did was broke it down from a 5th degree into a 1st and a 4th. So that adds back to a 5th degree. All right, and what you have to do is you have to keep pulling it down. So now you don't go back to the original. That's a mistake students make. You don't go back to the original. You pick up where you left off. You pick up where you left off. So you want to work on this part here. And if you want, you can do the rational zero test all over again if you like. Like we use -2 could technically work twice. But if you want to, you could also regenerate. So you could do 4 over 1, right? The constant over the leading coefficient. You could do that test again. That test that we did earlier. Here for the 8 over 1, you could technically do it again. Okay, so this could have a -2 in it again. It could have a -1 in it. You know what? I want to also look back at this for a second because I'm also noticing, did you guys catch this? Did you catch what we have here? This is a positive, this is a negative, this is a positive, negative, positive, and 0 would be a wild card. So we would actually say that this is what? What do we have right here? This would be a lower bound because you put in a negative and you have alternating output, right? If you put in a negative and you have alternating output, that's a lower bound. So from that, I could conclude what from my list? If -2 is a lower bound, then we know for sure that we wouldn't use this or this. But in our case, we only have one negative real zero, and I found it. I found it, right? I found it. So that means that I will not test anymore. But if I had to test more, nothing lower would have worked, okay? But I only needed one negative, and I found it. So I will now cross out all the negatives. I'll just write this out for you if you want to see it. Okay, so we only have one negative, so that's why you're using this information here to decide how much work and where you need to do it. So you found the one negative, so I don't need to test any more negative. So the only options left are these. It's a 1, 2, and a 4 in the smaller generated version. So like before, I'm going to go for the middle. I'm going to now pick a +2. Again, I'm not sure we have any positive real zeros, but now I'm going to look and see what we got. All right, so here we go. Let's generate this. And let me just check my signs because that was so close it looks like a shame. No winner. No winner here. Okay. Let's check all our signs. No winner. Okay. All right. So that doesn't work. All right, so let's try 1 because it looks like these are all positive and this is positive. So let's try a 1. So we'll try again now with a different number. Okay, wonderful. We've got a winner. So now what you have is you've broken down this part now. So now you have a linear, and a cube. All right, so let's write that down so you can see it. Now, if you've lost me a little bit here, I'm saying that this is x equals to 1. In the factored form, I'm going to move it to the left. So I'm going to do x minus 1. That's it in its factored form, which is what I'm writing right here, the factored form. And then this is what's left over. So this is your constant, your linear, your quadratic, and your cube. Okay, I'm just wondering if we want to handle this a little bit differently than the other one, or if you guys want to test it again. All right, well, let me see here. If we test it again, we just tried a 2, a 1. Let's put a 1 in again. Let me just move this sheet of paper. Let's put a 1 in again and see if it works twice. So that's the thing, sometimes when you test something, it actually works again, so you have to be careful of that. So what you want to do here is you want to keep breaking down the leftover. So I'm going to keep working on this part here. Okay, I'm going to pull down the 1. I'm going to add. Okay, and so what happened was that worked twice. That worked twice. And you will find that sometimes that happens, okay? Because your remainder is 0, it means that worked twice. Now, why I thought to do that, and I may not have been clear why I thought to do that, was because if you noticed right here, I put in a positive, and I got out all positives, which told me that was an upper bound. And if 2 is an upper bound, that meant that I shouldn't try 4 and I shouldn't try 8. So that only left me with 1 positive value, which was why I was like, okay, well, that looks like we should probably use it again because I don't have any other option. All right, so what you found here was the breakdown of the cubic part. So let's keep working on this because that's what we're doing. The whole goal here is to completely factor this polynomial. All right, so this cube part, this is your constant, your linear, your quadratic. So what's left now is you got out another x minus 1. And you were left with x squared plus 4. Okay, so that's what we just found. We found that 1 worked again, and we were left with x squared plus 4. So it looks to me like this is going to be complex. So I think you guys know how to handle that, but if you don't, let me work that out for you. Let me work that out if you don't know how to do that part. So if you remember from intermediate algebra, the only time you can factor is if this is a negative, right? If I don't have what I'm about to write. I do not have this. I do not have this. But if you had this, this factors. So when you have a difference of perfect squares, it factors into this. But I don't have a difference of perfect squares. I have a sum of perfect squares. So if we solve this, so I'm going to move the 4 to the other side. Now I'm going to take the square root. Don't forget that whenever you take a square root, you have to put a plus or minus in front, right? That's 2 answers. So now, you remember what the square root of a negative is? You remember what that is? That's a I. Right? The square root of a negative is I. The square root of 4 is 2. So that means that this is 2i. All right, this will solve into 2i. Now you want to put it in factored form, okay? Which means that if you have x equals 2i and you move it to the left, that's x minus 2i equals to 0. And if you have x equals to negative 2i, when you move it to the left, that factors into x plus 2i. So once it's down to the quadratic, remember, you're either going to factor it or use the quadratic formula to finish solving it. But there's no more guessing. There's no more testing once you're down to the quadratic level. We can solve anything in the quadratic level very easily. That's not like a guessing game when you get to that point. All right, so the final step here is me just factoring it. So I'm going to write that we have 2x minus 1s. And I'm going to list the zeros. If you have a repeating 0, you don't have to write it twice. You can just write it once. Okay, and those are the zeros. Okay, so this is the completely factored form, which was the goal of all the steps, all the tools to get this completely factored, and this would be the zeros. You don't really say X intercepts for complex numbers unless you're graphing on the complex plane. Then you can talk about this differently. But in a regular Cartesian plane, these won't show up. All right, so this is the factored polynomial. This is the zeros. Now let's go back to the original and just take a look at that. So if you notice, the winners